Today we will see Kruskals algorithm to find minimum spanning tree. Uh, there are two important algorithm available to find minimum spanning tree. First one is Prim's algorithm using greedy approach, and second one is Kruskals algorithm uh, using greedy approach to find the minimum spanning tree. Both algorithm is based on greedy approach, and we know what is spanning tree. There is a acyclic connected subgraph of the given graph is called spanning tree. Minimum spanning tree, the spanning tree has minimum weight. That is, there are n number of spanning tree for the given problem. So find the spanning tree with minimum weight is called minimum spanning tree. This weight is calculated as the sum of weight of all the edges in the spanning tree. That should be minimum. Now, we can apply Kruskals algorithm to find the minimum spanning tree for the given graph. And in the minimum spanning tree, there should not be any cycle, and the total weight should be minimum. And what are the steps in Kruskals algorithm? First, we have to find the edges with weight in the given graph and sort all the edges in the non-decreasing order, that is increasing order of the weight. Sort all the edges in the graph in non-decreasing. That means increasing order of the weight and initialize the sets. So we are going initialize disjoint set is empty. That is, it takes the edges with minimum weight and select the minimum edge. So among all the sorted edges, choose the first edge that is the minimum weight with edges. So that can be added in the spanning tree. And if only one condition is important in Kruskals algorithm, after choosing the edge, we are going to add in the minimum spanning tree. When we add the minimum spanning tree, there should not be any cycle. You should not form a cycle. Okay, if it is not a, if it forms a cycle, they just should not be added. Okay, choose the edge. If we add the edge in the spanning tree, we have to check whether it's a form a cycle or not. It does not form the cycle, we can add the edge in the spanning tree. If it forms a cycle, we can omit the edges from the spanning tree. And that is union of sets. Adding uh, edges in the spanning tree without cycle is called union of sets. And repeat the process till all the edges are completed. And output is the set of edges chosen in this manner is the minimum spanning tree. The output is spanning tree. So we are taking the graph with connected weighted graph as undirected graph. For this graph, we are finding the minimum spanning tree by applying Kruskals algorithm. The first step, write all the edges with weight. So we have to find out all the edges and write with the weight. And second step, sort all the edges based on the weight in increasing order, that is in ascending order. Now, choose the first one BC, add it in the spanning tree. Next, choose the next edge EF. When we add EF, should not form a cycle. So when we add EF, there's no cycle in the spanning tree. And third one, choose the edge AB. If we add AB in the spanning tree, already B is there, just we can add A. So the AB cost is 3. If we are adding A, B does not form a cycle. And fourth edge is PF. Choose the next one, BF. Add BF in the minimum spanning tree. There is no cycle, so we can add it. And choose the CHCF. If we add CF, it form a cycle. CFBC, it form a cycle. So we should not add CF. That can be eliminated from the list. Then choose DF. So if we add DF, there's no cycle, so we can add DF. And next remaining, you choose AF. If you connect AF, it form a cycle. Choose CD. If we connect the edge CD, it forms a cycle. EA also it form a cycle, and DE also form a cycle. Now all the edges are over. Check the spanning tree whether all the vertices are added in the spanning tree. Yes, A to F, all the edges are added in the spanning tree. This is a final minimum spanning tree for the given graph using Kruskals algorithm. Total cost of the minimum spanning tree is sum of weight of all the edges in the spanning tree. So that is, add the edge weight, the total weight will be 15. That is the cost of minimum spanning tree. So Kruskals algorithm produce the minimum spanning tree for the given graph using greedy approach. And we will see the algorithm. Algorithm name is Kruskals to find minimum spanning tree. Input is graph. So here the input is graph is collection of vertices and edges. Output is minimum spanning tree, that is with weight and edges. Now sort all the edges in increasing order of the weight. So weight of E1 should be less than V2. So that should be ordered in ascending manner. And initially, spanning tree is empty. Take count equal to 0 to find um, whether all the vertices are added in the spanning tree or not. So while count is less than A of V minus 1. So the loop is repeated for all the vertices except 1. And K equal to K plus 1. So we are taking the first edge. Choose the edge ET union EK. It is acyclic. Choose the edge with minimum weight. When we add edges in the spanning tree, it should not form a cycle. If then we can add edges in the spanning tree, increment the count value. Count maintains number of edges in the spanning tree. This process is repeated for all the vertices. If all vertices are added into the spanning tree, the process can be stopped. So output return ET. ET is a minimum spanning tree that can be written as an output to the user. And what type of data structures we used for implementation? That decides the time complexity. The time complexity refers the time taken by the Prim's algorithm or Kruskals algorithm to produce the minimum spanning tree. So it can be implemented using adjacency matrix or adjacency list. Array is used to implement matrix, and list priority queue. So minimum heap is used to implement um, Kruskals algorithm using adjacency list for implementing priority queue. And we will see the complexity analysis. Adjacency list and priority queue. The time complexity of Kruskals algorithm is order of E into log E. E represents number of edges in the graph. So here in this Kruskals algorithm, we are taking all the edges and the edges are processed with weight. So the priority queue choose the edge with minimum weight. So time complexity of priority queue is order of log E. So the total complexity of algorithm using adjacency list and priority queue is order of E into log E. And the space complexity is order of V plus E. That is the memory space occupied by the algorithm to produce the minimum spanning tree. V is number of vertices and E is number of edges. The time complexity of Kruskals algorithm is order of E into log E. Space complexity is order of V plus E.